Welcome to the next video of Chapter 6 on rational exponents and working Worksheet 3. We're going to start off with just the basics, and I think we were talking about this in class. So let's just think about square root of 4 and how, notice that the square root right here with the radical sign, I've gone ahead and I put the 2 in the root. That means square root. Normally, if we don't put it there, we all assume that that's a 2. And then I've got an exponent on the outside. The basis for the exponent is 3. Let me repeat that one more time. Root, base, exponent. If I take the square root of 4, I get 2. 2 cubed is going to be 8. So this one was really easy to work out. Well, let's just think about this. 4 squared. You know 4 squared is 16. And you know 4 to the 1 is 4. 4 to the 0, we've learned in the last video that 4 to the 0 equals 1. And 4 to the negative 1 means I flip the 4 on the other side of the fraction, meaning that I get 1/4. Now, what about 4 to the 1/2? Notice that I've got 4 here. So it's got to be somewhere in between 4 and 1. Well, what's halfway in between 4 and 1? Because this is 1/2, right? So what is halfway between 4 and 1? 2. Okay, well, if I take 4 to the 1/2, this is my base. The 1 on top is the exponent, but the whole thing is actually called a rational exponent. Okay? But the 1 on top is an exponent, and the 2 is actually the root of the radical. Okay? So, here's my root. Here's my 4. Square root of 4 is 2. I can write them both ways. So let's do that. For a rational exponent, I'm going to write it 4 to the 1/2. If they ask me to put it into radical form, I'm going to write the radical, and I'm going to make sure that I put a 2 in the root. Why is that? Well, because we're going to have more than just a 2. So I'm going to list out all the ones that I think you really need to memorize for this chapter, which these are the basic ones. Square root of 4, square root of 9, square root of 16. You need to know the answers for all these. You can just put them in your calculator. All right, so we have square root of 100, square root of 121, which is 11, square root of 144, which is 12, square root of 169, which is 13. We're going to stop there on the square roots. The cube roots are cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5. The fourth root of 16 is 2. The fourth root of 81 is 3. And one more. The fifth root of 32 is 5. Or excuse me, is 2. Okay, so now we've got the square root of x. Okay, notice that I've got the square root of x squared. Let me think here. When you take this like this, you could actually write it like this. So the 2 going here or this 2 going here, those are both the exponents. It really doesn't matter where they go. Okay, you might see this format more from some of our problems. So what is the square root of x squared? Basically, we've talked about this before in the last chapter. The square root of something squared is just what's under the bottom, right? What's under the radical. So the square root of x squared is just x. Okay, let's do this one again. So again, the square root of 3 squared. Well, what's 3 squared? 9. So the square root of 3 squared is really just 3, right? Whatever's under the radical. I can still write it both ways, but the answer is just going to be 3. And let's just take a weird one, like 12, which you know is not going to break down, or is going to break down, but you're going to end up with a radical. So let's see here. We've got the cube root. All right. Wait a second. I just added a different number. That's the cube root. But as long as I have the same number here, the cube root of 12 cubed, really doesn't matter what 12 is going to be. Whatever's under the radical is the answer. So it's got to be 12. Okay, let's do it again. Now we're going to use rational exponents. We're just going to use the x example. The root is 2. The exponent is 2. So if I were to write it as rational, I would have x to the 2 over 2. Okay. Which is still just x to the 1, because isn't 2 over 2 just 1? So there I've also done it a different way, but I've also shown that the square root of x squared is still just x. So I guess you could say this is another proof, like in geometry. Okay, so we're doing the square root of x to the 12th. Now I wrote it the other way, just one way. Okay, I've taken the 12, which is the exponent, and the 2, which is the root. I'm putting it on the bottom of the fraction that's in the exponent. 12 divided by 2 is what? 6. That one came out real nicely, didn't it? So this is another way to simplify a rational. By putting it into the rational form right here, I can reduce it pretty easily. Okay, the cube root of x to the 5th. Okay, so the 3 is the root. It goes on the bottom of the fraction. And I can't reduce this. So I'm not going to make a decimal or anything like that. I'm just going to leave it x to the 5/3. And again, if I were given this, I'd write it like this. If I were giving this, I would write it like this, depending on what the instructions are. Because on the test, it's going to say, write it in radical form, or write it in the rational form. This is radical form. This is rational exponent form. Okay? All right. Now, look at your worksheet number 3, 1 through 4. If you have any questions on 1 through 4, please look at the video that I've already done. So everything up to this point in this video, you should be able to work questions 1 through 4. Okay? If you have any questions, email me. Now we're going to take a couple of the problems that are on the rest of the worksheet and work those problems. And we've got about 3 that we're going to work, and those should actually give you enough to work the rest of worksheet number 3. So let's look at number 8. We have negative 64 to the 2/3. I'm going to write it as a radical. So I have the 3 goes in the root. I have negative 64. I'm going to leave the 2 on the outside, which is the exponent. Okay, what is the cube root of negative 64? Well, the cube root of 64 is 4. So just think about it. If it's a negative, we are going to think about negative 4 times negative 4 times negative 4. I'm looking for 3 of something that'll make negative 64. Does 3 negatives make a negative? Yes, it does. So the answer is negative 4. Okay. Now, I'm going to say one thing that will be very important for this chapter. In this chapter, we will not have any imaginary numbers. So there will not be a need to take out a negative and make an I anywhere in this chapter. That was only in chapter 4. All right. So We have -4, -4 squared. What is -4 squared? Positive 16. Remember, the negative times the negative gets positive. Okay? All right. Now, let's do this again. So the next problem that we've got is problem number 9. Okay, 16 to the 1/4. Remember with exponent rules that 1/4 can be applied to both the 16 on the top and the 16 and the 81 on the bottom. There is no need to basically reduce 16 over 81 first. Let's just make 16 make the 4th root of 16, and let's just have 81 and use the 4th root of 81, because 1/4 has to be applied to the 16 and to the 81 since it's outside of the parentheses. All right, well then that actually makes it really easy, because look at this right here. The 4th root of 16 is 2. The 4th root of 81 is 3. So if I can just write out my answer, 2 over 3, well, that's it. Okay, one more problem. Okay, we're going to do 14. 14 will actually let you do all the rest of the problems. Okay, so the reason is because we're going to take the 25. So when you have a whole number with a rational exponent, work everything this way. When you have a variable with an exponent and another exponent, work everything the way I'm going to show you. So we're going to split this up. Remember when we were talking about exponent rules and I said to split everything up? Watch, 25 to the what? -3/2. And the b to the 6 gets what? The 3/2 as well. Okay, so what did I just do? I took 6 times -3, which is -18, over 2. And that's because this 6 right here is really over 1, and you just multiply across when you multiply fractions. Okay, so I've split them up. Now I'm just going to do the 25. What's the square root of 25? Because the 2 means square root, and the -3 means an exponent, and a negative on the exponent also means that I'm going to have to flip it over on the other side of the fraction. Okay? So the square root of 25 is 5. I'm going to flip it on the bottom, so I've got 5 cubed on the bottom. Remember that when you have a negative exponent, that negative exponent is going to, the negative is going to go away, but the 3 still needs to be there, so, because the 5 and the 3 both flip to the other side of the fraction. All right. Okay, so what was -18 over 2? -18 over 2 is really just -9, and a negative means I flip it as well over on the other side of the fraction. So when I flip, if I don't have anything on top, I'm just going to put a 1. But b to the 9th needs to go right here with my 5 cubed. What else do I need to do with this? Because this is actually looking pretty good since I've done the 25 and the b. The only thing I need to do now is this 5 needs to be cubed. Okay, don't leave any numbers where if it's the variable, fine, leave it with this exponent. But if it's a number, we need to figure out what that number is. So my answer is going to be 1 over 125 b to the 9th. All right. Thank you for watching this video today. This is worksheet number 3. Worksheet number 2 is coming. And again, this is going to be a little different. It's more new stuff than what you've seen in Algebra 1. And if you have any questions, send me an email.